Hi everyone, there was a situation with my headset. I just want to check in and find out if you guys can hear me now. Okay, it seems like Bianca says everything is fine now. All right, sorry for that. Okay, so automation in Autodesk Inventor. I'm quickly going to discuss today with you who Baker Baines is, and then we will discuss what design automation is. We will work through some practical applications and then see the benefits of design automation, do a little bit of automation setup, and then closing. So we are running a campaign and walking you through the steps that you need to get to design for the fourth industrial revolution. And in the previous event we had last month, we discussed a few steps which we've identified as Baker Baines. And we've identified the change from your 2D to 3D designs as the first step. And the second step will be design automation, which we are going to touch on today, and then a few more webinars after this as well. So my name is Yolandi Burger. I'm a manufacturing and process plant specialist. I've got a mechanical engineering diploma and over 10 years experience in the drawing office. I used to be a supervisor. And just a fun fact, everyone calls me a philosopher. I like to think about things and sometimes think too much about it and just need to calm down and just reevaluate what I'm actually supposed to do because I am going off in tangents. So hopefully that will not happen today. So Baker Baines has evolved over the past 6 years from being an Autodesk reseller to a consulting company. We set out to solve our customers' problems through digital transformation, and we help you to design and make a better world. In doing so, we offer various business process improvement consulting services, survey and design hardware and consulting, design software consulting, and we top it off with a blended learning approach to how we believe our customers can or should digest information. So I've got a poll question here for you. I would just like to know the basic question we usually ask. How familiar are you with Baker Baines? It's very familiar, somewhat familiar, not familiar at all. Some of you might be clients, but you don't really interact with us directly. You work through a manager. Some of you are not clients and are just checking out what we're all about. We would just like to know, to make sure that we actually address all the issues, all the different types of people that's listening in. Okay, I think that is enough. Thank you very much. Design automation, it enables you to capture and reuse engineering knowledge and intent. Automation not only helps reduce errors and time spent on tedious errors and repetitive modeling and tasks, but it can also be scaled to streamline downstream development processes. With the fast pace of modern technologies, designers and engineers constantly have new software at their fingertips that empowers them to enhance their approach to problem solving. With this consistent flood of new tools, it's important to consider if the next best thing is critical to your workflow, or if you will be simply investigating in another passing trend. However, some solutions showcase such dramatic efficiency gains that there is no denying the benefits of their implementation, and design automation is definitely one of them. Design automation is an approach that helps you capture and reuse engineering knowledge and intent. Automation technology enables you to easily utilize rule-based design without needing to know how to code. As a designer and/or engineer, do you find yourself spending excess time completing repetitive tasks? modeling standard features, or configuring products to custom specifications? Do you wish you could free up the time to focus on projects where you add unique value, innovating to create better products? Automation of your processes can help you advance projects to completion in mere seconds, which frees up valuable time for the tasks that require your level of skill and engineering knowledge, no matter the size of your company, or whether you are fabricating and manufacturing many different types of products or just a few. There are likely repeatable patterns and workflows in every design. What was it that inspired you to become an engineer? Was it solving complex problems or bringing new designs to life? Now compare that to how you actually spend most of your time. How do we deal with all those routine tasks that interrupt us when too much must get done? Your factory floor uses automation. So why not bring a little bit of that into the engineering offices? So with iLogic technology, design automation saves you time by reusing engineering intent. We created iLogic technology for use inside Autodesk Inventor. There are no expensive third-party add-ons. It's all included. Using parameters that you have defined in your model and a vast library of code snippets, it's very inexpensive. So the next time you need to design, just input the parameter and the work is done for you. It is that simple. So using Inventor is not just about moving from a 2D world over to 3D. It's about designing your concepts and ideas more efficiently. In order to do that, there has to be some sort of automation involved. Design intent, for example, enables you to predict how your parts and assemblies will behave. Inventor provides you an opportunity to describe your model or build intelligence into it so that the inevitable changes that happens can be expected by you. And those changes propagate to downstream applications like drawings, analysis, and CAM toolpaths. They all update according to your modifications to the geometry. And also, specialized tools are available for several model types, including sheet metal designs and plastic part design. These features make it easier to model in 3D and provide all the engineering criteria for bend allowance, so you know your parts are accurate according to the machines used to make them. There are plastic part features that are specifically designed to make modeling faster, such as boss features for fasteners. Lip and groove features are often part of plastic part design and is done quickly in Inventor. There is the snap feature for common shapes, for snap fits between components, and those are just a few of the examples of features that are going to make plastic part design more of a design task rather than a 3D modeling challenge. Let's take a look at some of the features included with sheet metal design in this short video. Autodesk Inventor has tools specifically for the design and development of sheet metal components. These tools follow the standards you define, such as sheet metal thickness, bends, corner treatments, and unfolding rules to ensure your designs meet manufacturing requirements. Commands such as flange, hem, and fold automate the creation process of standard sheet metal features. The punch tool, corner seam, and corner treatments ensure that when you're modifying your design, that they continue to follow your sheet metal standards. And your standard 3D modeling tools, such as rectangular pattern and mirror, allow for quick development of sheet metal components. When you're ready to create a flat pattern, Inventor does all the calculations for you. Again, based on your manufacturing standards, ensuring you have an accurate 2D profile for downstream use. Autodesk Inventor provides you tools to easily document both your folded and flat patterns. When you're ready to share your design with manufacturing, you could create a simple DXF, or you could take advantage of Inventor nesting to automatically create nests of your flat components. Inventor nesting automatically groups components of similar material types and thicknesses into individual sheets. Sheets can be defined to match the material you have on hand for creating components. Inventor nesting then automatically calculates nesting efficiency based on parameters and options you define, such as mirroring, spacing, and rotating. And this will help you to better connect your designs to downstream manufacturing processes. And there is more. Weld frame design only requires you to build a wireframe and select structural profiles for them. Even solve your weld frame in seconds using beam elements. Tube and pipe contains all the hardware you need for applying your roots for rigid pipes, bend tubes, and flexible hoses. Just draw the root wireframe and specify the material and the components that are included. The nature of structural frame design with standard frame profiles and format treatments makes a relatively simple yet tedious modeling task. That's perfect for automation. Autodesk Inventor makes frame design simple with tools specifically created to make inserting frame members, applying end treatments, and analyzing the performance of frames. Let's take a look, starting with parametric skeleton geometry for the frame. You can begin inserting frame members by specifying the family, size, and material from a library containing thousands of standard profiles. Inventor gives you complete control over the placement of each member. Pick sketches, edges, or points to position your frame members, with options to offset or rotate the frame profile relative to the geometry selected. Once the size and placement of the frame members are determined, the frame members are inserted into the assembly and automatically numbered based on your preferred file name and part numbering scheme. As you add more frame members into the design, corner treatments can be used to trim, miter, or create notches between members, and end caps can be inserted from the content center to determine free ends. The standardized nature of frame design also makes it easy to set up and perform structural analysis. To make sure your design performs as required, just add your constraints. The solve time for frame analysis is super quick, so you can immediately begin reviewing displacements and stress results to determine if further design refinement is required. With automated commands for designing structural frames and a simple-to-use analysis environment, to make sure your designs will perform to requirements, Inventor gives you the professional-grade tools you need to get frame design done fast. So purchased components are the last thing you want to spend time modeling for. Inventor has you covered. You can choose from hundreds of thousands of standard components for your design. Even use our design accelerators to create specialized components like gears, bearings, and cams. It also contains engineering calculators that are built inside Inventor. All the most important tools you need from your machinery is in this handbook. So you don't want to spend time modeling standard components like nuts and bolts that you don't have. The Autodesk Inventor Content Center allows you to generate over 750,000 standard components, from fasteners to shaft components and from rooted systems to structural steel. The Content Center libraries cover 18 international standards, including ISO, ANSI, and DIN. In addition to the standard components included, you can also publish your own parts and manage them with Content Center. Let's see Content Center in action. In this example, Parts are inserted directly from the content center. Notice how the parts automatically size themselves to suit the features selected. Once inserted, content center parts can be resized or redefined from the library and contain all the information needed to automatically populate your bill of materials. Content Center supports Inventor's design accelerators, a collection of rule-based design tools that allows you to quickly generate components around your functional requirements. Add fasteners or design a frame, power transmission or spring system directly from Content Center components. No need to model any parts yourself. In the Inventor rooted systems environment, Content Center provides components for your piping runs and cable harness. Design mechanical systems which include flexible or rigid piping routes using your existing geometry as a reference. Content Center supplies hoses, pipes, tubes, and industry standard pipe fittings such as flanges and couplers. Design electromechanical systems which are linked to your AutoCAD electrical schematics. And you can populate your design using the AutoCAD electrical data and Content Center's linked libraries of components. You want to spend your time engineering and designing, not modeling. Autodesk Inventor's Content Center libraries save you time and effort, reduce modeling time, increase standardization, and make use of Inventor's design accelerators with Autodesk Inventor's Content Center. I'm going to list a few benefits that you can get from this design automation. So you can design more efficiently. Sheet metal parts and welded frames often include standard features that require simple yet tedious modeling. You can eliminate your busy work by automating the creation of typical product features. You can rapidly configure products to specifications. You can manually modify models to meet customer specs, and it drains engineering resources. By defining parameters, you can create your 3D models and easily set rules that drive the custom product configurators. You can accelerate handoff to manufacturing by extending automation beyond engineering with simple-to-code tools that capture and execute standard processes for the creation of drawings, toolpaths, and other documentation. Another benefit is drawing creation. So let's say you are a manufacturer that have many templates from printing different sizes of components or for use with different customers. Depending on your business, the number of templates you have could quickly become overwhelming, especially to a newer engineer who might struggle to determine which template should be selected for different use cases. Using automation in your CAD software, you can create a simple form for engineers to complete that will automatically generate the drawing for the specific model or component the engineer is working on. These forms might contain questions like, should measurements be displayed in metric or imperial? Who is the customer? Is the drawing for something being fabricated or for assembling components? By automating the creation of drawings using standard drawing templates, you can save time and increase consistencies. So when doing drawing creation, if you have an automated system, you can create complete drawing sets automatically. You can define and generate drawing views, add dimensions, generate or update your BOM, your information and balloons. You can modify or add title block parameters, update all drawings to comply with new CAD standards. You can check for CAD Standard Compliance, and you can do batch, publish, or export. Another benefit is the standard compliance. So CAD modeling checks are often complicated to review. Using automation, you can scan for things like fully defined sketches or consistent modeling practices. You can also check for clashes or interferences. If the components overlap or clash in your model, then they will clash in real life, which could mean a costly last-minute adjustment. Clash detection can also be used as a collaboration tool. In this case, clashing your model against another company's model to make sure that the two designs will fit together when manufactured will be a great help. Data checks could be the most boring task in your standards compliance process. So why not let automation handle this for you? You established engineering intent during the design phase. So you're already set up to run a script that can tell you if all properties are filled out appropriately in your CAD models, or if important information like the components material is selected. So assembly checks can help you when you're designing for manufacturing. It often takes more time to check and review a design than it does to create it. Many people are typically involved in the process, and everyone must agree on the best design to allow more opportunity for engineering review. You can gain significant time by automating the process of checking things, like can all components be manufactured from standard sizes of raw material? And or are there any undercuts, deep pockets, or other features that can cause problems for the CNC machine? When it comes to new product configuration, sorry, now that we spoke about the automation tools for design work, we will take it up a level. So Inventor offers the ability to capture the engineering rules of your design so that you can make reuse of it in rapid configurations. So how it works. Think about the last time you reconfigured the standard model. How much time is spent on making changes to the design and all the manufacturing drawings that are sent to the shop floor? With automation, you can set rules that drive a custom product configurator right inside your CAD software and eliminate the rework that comes with repetitive tasks. First, build the logic that drives your configurator using the parameters you already captured when creating the 3D model of your design. Essentially, what you are doing is describing your design beyond the dimensions, constraints, and formulas you have in your model, and you are adding engineering rules so that the changes to the design specifically happens automatically. Some 3D CAD systems, including Inventor, include a library of code snippets. It makes it easier to define these rules. When your design intent is embedded into the 3D CAD model of your design, you can further improve the communication of your design intent by adding a form. A form is a dialogue you can add to your design to help communicate which parameters can be edited and what the result should be. This embeds knowledge into the design, making it easier for users who are unfamiliar with the design to know what changes they can make without inadvertently creating a design that falls outside of the design scope or that can't be manufactured. A junior designer or even a sales engineer can configure a design to customer requirements, safe in the knowledge that they can't make any mistakes, without taking up engineering time that can be better used on your ongoing projects. Additionally, iLogic technology in Inventor can be used to change the design of your model itself. For example, if a part gets too long, your software could automatically change the material from aluminium to steel to increase the strength of the customer's load requirements. Now, a growing number of companies and individual Inventor users are witnessing the power of implementing iLogic in their daily activities to improve their efficiency, not just in design, but also in manufacturing software that works in Inventor. So making changes to your design is easy when you include good design intent. You can make it even easier by specifying values that are open for change. So product configurators have been proven to save engineering time and accelerate sales growth of custom products. In the past, setting up the rules and logic behind the configurator and making it accessible to sales reps and engineers often required specialized programming knowledge, significant investment in development, and a lot of time. With Inventor, however, setting up and deploying a product configurator has never been easier. First, you must define the logic behind the configurator. This is easy to code with Inventor iLogic technology. Next, once logic has been defined, You can create forms inside Inventor to provide a more intuitive front end for the configurator. Simply select which parameters, rules, and iProperties you want available for configuration, and they are automatically added to your form. No programming required. These can be grouped together on the form or separated into different tabs for better organization. You can even add text and pictures to provide instructions or describe parameters. With the product configured, unique customer requirements may require additional fine-tuning. Inventor Nastran is integrated directly inside the CAD environment, so you can quickly perform advanced stress, fatigue, and thermal analysis to evaluate the performance of the desired design. iLogic can also automate the entire process of setting up, running, and post-processing the simulation, which reduces the time it takes to get to actionable results. Automated design and configuration processes help you get from design to manufacturing faster. In other words, with rule-based design, you can deliver custom products faster and improve your bottom line. Fragmented and inefficient processes in your manufacturing workflow can affect your bottom line, impacting the profitability that can be extracted from any project. Difficult and time-consuming manual setup reduces the productive machining time of your CNC milling machines, which is why automation of these processes is an ideal step towards maximizing productivity. The integrated platform of Fusion 360 means that part programming and part setup on the machine are unified into a single user experience, letting you quickly and accurately set up your stock material or parts process, components on the machine tool, and create your required toolpath without leaving the Fusion 360 environment. Probe features and part alignment sequences are created offline and included at the start of your Fusion 360 manufacturing process to set up your part. Once post-processed is NC code, the measurement sequence can be run on the machine using a machine tool probe. The result written to the controller is a text file and can be read back into Fusion 360, automatically generating a part alignment which adjusts the part based on a series of linear translations and actual rotations of the part. What's more, the same technology can be used for part verification without taking the part off the machine. This allows the part to be checked before moving to subsequent operations or final inspection. Unexpected variation can be detected and remedied immediately, minimizing costs and improving efficiency. By using Fusion 360 as an integrated solution for design, manufacturing, and part setup and verification, you can remove non-productive operations, start machining quicker, and realize the full potential of your CNC and milling machines. So Fusion 360 unifies design, engineering, electronics, and manufacturing into a single software platform. Fusion 360 is the first 3D CAD, CAM, CAE, and PCB tool of its kind. It's connecting your entire product development process into one cloud-based platform. So let's look at the cloud. So once you've spent time defining automations that streamline your workflows, you can begin considering ways to expand your level of efficiency even more by extending your automation to the cloud to support corporate initiatives. You can have running scripts. With automation APIs, you can run your configurations on the cloud and continue to work efficiently on your local machine. These types of jobs could be highly repetitive or may need large-scale processing power. Leveraging data across IT and OT systems. The automation API enables you to exchange product data with various business systems such as ERP, MRP, MES, PLM, and CRM for production. By linking data in the cloud to other systems, you can leverage third-party data formats. within your own automation workflows. You can empower your sales team. Automation can streamline the product ordering process for your sales team and customers. By extending your product configurator to the cloud, your sales team can respond faster to customer inquiries and quickly generate more bids or proposals at a lower cost. They can ensure complete and accurate quoting for sales configurators, and they can supply technical drawings or 3D CAD models of the configured design. So as discussed in the start of this webinar, this is part of a series where we are discussing the steps to follow to get you to Industry 4.0. So next week we will have a hands-on session to introduce you to Fusion 360. Please register for that if you would be inclined to learn a little bit about Fusion 360. And next month, I will continue with the automation webinars where I will show more practical examples of how you can use Inventor automation in your everyday designs. So you might be a customer that say to me, we don't even have the software to enable us to automate. And I can reply and say, please contact us. We sell the Autodesk products and we can help you decide which is the best fit for your organization. You might be one of those customers who are not sure if you can move to the next step in Industry 4.0. So we can assess your business and we can create a tailor-made strategy to get you on your way to Industry 4.0. Or you might be one of the companies that says that your staff is not completely trained for this task. They know Inventor, for instance, but they're not too sure about automation. We can arrange for training on site and customize it to your needs. We have a specialist series that tends to this specific type of training that can show you guys how to do automation. It can show you how to work with parameters. It can show you iLogics, iParts. Just contact us and we can arrange to sit down with you and customize it to your needs. Just another poll question quickly. I would like to know, are your company ready to automate your designs? You can answer by yes, we are ready and we know what to do. Yes, we are ready, but we need more training and or guidance. And no, we are not ready. We need guidance on what to do next. Hi, thank you very much for all the answers. We will work through this and give feedback when time is due. So I adopt with Baker Baines. I adopt is our unique consulting methodology where we help our clients. And in a case like today with automation, where we are all working towards the fourth industrial revolution, what we would do from our side as Baker Baines is we will help you to develop and implement a digital strategy to transform your business and your process to adapt to this automation. We can help you optimize your business processes and your workflow, adopt the technology, and design and make a better world. And the benefits of this is that we are solving your problems. We are working with you to make sure that we get tangible outcomes that actually makes a difference in your life and in your company. We will holistically address the organizational issues that you experience, and we go beyond the CAD environment. And this also includes change management. So if you would like to get in contact with us, we are online in LinkedIn, Facebook, Twitter, Instagram, YouTube, on the following paths that you see on the board. And then our support line, we are open from 8 o'clock to 11:30 from Mondays to Fridays. At our normal office number, 011-568-2060, or you can email support@bakerbains.com any time of the day, and we will respond as soon as we can. Thank you so much for taking the time to sit through this webinar with me. I'm really looking forward to next month's webinar, where we are going to take real life models and work with it and show you how you can change it and make it easier for yourself, working a little bit with parameters, iParts and iLogic. And I am looking forward to that and hoping you are too, hoping to see you then. So we solve our customers' problems through digital transformation. We help you to design and make a better world. Enjoy your weekend. Bye.